Hello, grade 6. So this is our fourth online lecture. In this lecture, I'm going to explain a new chapter, which is triangles. Let us talk about our objectives to identify a triangle and its elements. We are going to identify also particular triangles. We are going to learn how to construct a triangle and how do I calculate the missing angle in a triangle. Let us start first of all. If you can see, we have three non-collinear points, A, M, and E. So going back to the word collinear, collinear means they form a straight line, but as you can see, the points A, M, E are non-collinear, so they don't form a straight line. The first question is to draw the segments MA, ME, and AE. So I'm going to join AM, ME, and AE. Now, what do you call the obtained figure AME? We call it a triangle. So a triangle actually is formed when I join the segments of three non-collinear points. They form a triangle. So in another word, we can say that a triangle is formed of three segments. Let us continue now. If you look at the triangle BON, okay, let us name the vertices, the sides, and the angles. Do you still remember those three non-collinear points? We actually call them vertices. It's from vertex. So one vertex, three vertices. So from the word triangle, it's three angles, three vertices, and three sides. Okay, so first of all, the three vertices of triangle BON are B, O, and N. So three vertices, B, O, N. Now the sides are BO, BN, and ON. So three sides and three angles. What are the angles inside this triangle? The first angle is BON, ONB, and OBN, so three angles. Well, if you can check the angles, the vertex of the angle in the first one is O, the vertex of the second angle is N, and the vertex of the third angle is B. So, three sides, three vertices, and three angles. And we can say that side BO is opposite to the angle BNO. Let us complete together. The side, which side is opposite to the angle OBN? It's ON. And the side BN is opposite to the angle BON. So every angle, it has an opposite side. Okay? Now, you name a triangle using its three vertices. It has three sides and three angles. This is the main point. Let us practice this exercise. So we have a triangle LUI. So LUI, vertex L, vertex U, vertex I. Okay? Let us write the angles in this triangle and try to put its opposite side. So the first angle is LUI and the opposite side is LI. The second angle is ULI and the opposite side is UI. The third angle is UIL and the opposite side is LU. Now let us talk about particular triangles. You know that we have triangles that are special or particular. The first particular triangle is the isosceles triangle. Okay, so this is a new word, which is isosceles. Well, actually, the word isosceles, it comes from isosceles. Iso means equals. Okay, so isosceles triangle, it's a triangle. It has two equal sides. Two equal sides and two equal angles only. So you know that we have three sides, three angles. In the isosceles triangles, we have two sides equal and two angles are equal. So if you look at this figure, we have the triangle ABC. It's coded that the side AB is equal to the side AC. Okay, and those angles that are on the base are also equal. So angle ABC is equal to angle ACB. So it's necessarily it's an isosceles triangle. Then two sides are equal and two angles are equal. Both of them satisfy the isosceles triangle. So we can say that AB is equal to AC. AB is an isosceles triangle. A is the main vertex. BC is the base. ABC equals ACB. So guys, pay attention. When I say that ABC and ACB are equal, then A is the main vertex. This is very important. You cannot tell me it's an isosceles triangle unless you tell me which one is the main vertex. Because if you tell me which one is the main vertex, I would be able to know what are the equal sides and what are the equal angles. So for example, suppose without a drawing, I told you that triangle EFG is an isosceles triangle of main vertex F. Okay, EFG is an isosceles triangle of main vertex F. That would tell me that FE equals FG. And that also will tell me that FEG, the angle, is equal to FGE, the angle. So keep in mind that it's very important to tell me which one is the main vertex. Let us take another example. Suppose I told you that triangle KLM is an isosceles triangle of main vertex M. What does that mean? KLM is an isosceles of main vertex M. That means ML equals MK and MLK equals MKL. Okay, guys? So pay attention. You start by the main vertex and you tell me that MKL equals MLK and MK equals ML. So it's very important to mention the main vertex of the triangle. So what did we learn now? We learned that there's something called isosceles triangle, and in the isosceles triangle we have two equal sides and two equal angles, and we have the main vertex, which is very important to identify what sides are equal and what angles are equal if you don't have a drawing like in this case. In this case, we already it's very obvious to know that AB is equal to AC because it's coded. But suppose we don't have any drawing, so the main vertex would help me a lot to know which sides are equal and which angles are equal. Okay? Now let us go for the second particular triangle, which is an equilateral triangle. And a triangle is said to be equilateral if it has three equal sides, three equal angles. And in this case, we don't have a main vertex because all of them are mains. All of them, they are equal. They have the same value. Okay, so if you look at the figure, we have a triangle DEF. It's an equilateral triangle. So DE equals DF equals FE. And DEF equals DFE equals EDF. And all of them are 60s because you know that a triangle, it's 180 and all of them are equal, so we divide the 180 by 3, so each one of them is 60. Okay, we are going to learn about this later on, never mind, but you have to keep in mind that in an equilateral triangle, because we have three equal sides and three equal angles, each angle is 60 degrees. So till now we learned two particular triangles, the isosceles triangle and the equilateral triangle. The isosceles triangle, two equal sides, two equal angles. The equilateral triangle, three equal sides, three equal angles. The third triangle, which is the easiest one because you already know, it's the right triangle, and it's very obvious that in a triangle it's said to be right, at least it has a right angle. Okay, so if you can see LIT, in the adjacent figure, we say that LIT equals 90, then LIT is a right triangle at I. Okay, so keep in mind, when I say LIT right at I is the right angle. EFG right at F means F is the righty, not 90. Okay, so when I say right at I is the 90 degrees. Not also, this is important. You have to know that the side which is opposite, do you still remember that when we said that we have sides opposite to the angles? The side which is opposite to the 90 degree is said to be hypotenuse. We say that LT is hypotenuse. Okay? And you know that the other two angles, they are 90 and they are also complementary. Why? Because the I is already 90. It took 90. L and T, the remaining for both of them is 90. So we say that they are complementary. So let us take another example. Suppose I told you that EFG is a right triangle at G. Means G is 90 and EF is the hypotenuse. Okay, because it's the side opposite to the 90 degree. So the three particular triangles are isosceles, equilateral, and right triangle. Okay, after knowing the particular triangles, we are going to learn how to construct a triangle, and this is the most important thing you have to learn in this year. Okay, I want you, when you go to grade 7, you know how to construct the triangles. In construction of triangles, we have three cases. I would tell you to construct a triangle that has three sides. I give you the first side and the second side and the third side. And I would give you two sides and one angle and two angle and one side. Let us start by the first case. Suppose I told you to draw or to construct a triangle that I gave you three sides. You have to know that you need to use a ruler and a compass. What are the steps? First, you draw any of the three sides, but we mainly choose the longest one. Then we use a compass, okay, to draw an arc as much as I gave you. For example, if it's 5 centimeter, you open the compass 5 centimeter. And if the third one is 6 centimeter, you open the compass 6 centimeter and you draw another arc. And the point of intersection of those two arcs is the third vertex. Now, we will watch together a video that explains the steps of construction of this triangle. So I want you now to listen to this video, okay? You are going to see the steps of construction of this triangle, okay? So pay attention. Let us start this video. Okay. As I told you guys, so you have to choose the longest side and draw it before, okay? Till 7. This is 7 centimeters, okay? Now we are going to use the compass. Open. So open the compass 5 centimeters, as you can see, till 5. Put it on the end point. fix the compass and draw a small arc, as you can see, okay? That's enough, okay? So the first step is to draw an arc, which is 5 centimeters. Now, we are going to draw another arc, which is 6 centimeters. How? We are going to put the compass on the ruler, open it now, centimeters, okay? 6 centimeters now. Now put it on the another end, another arc, okay? Very good. Now, the point of intersection of those two arcs is the third. This is the third vertex. And now I join this vertex with the endpoints. And one till the other endpoint. Okay, and this is the triangle. Now you can remove the arcs. You can erase the arcs if you want. Take them away. Okay. Now, if you want to check that your answer is correct, this should be 5 and this should be 6. To make sure that your answer is correct, you can use the ruler and measure them. This should be 5 and this should be 6. And that's what they did, actually. They measured it. You can see them. This is 5. Exactly. And the other side is also 6 centimeters. Great. Okay. 6 centimeters. And that's how we construct a triangle with 3 sides. So the first step, you choose the longest and you draw it. Then you use the compass. You open it as much as I want, or as much as I gave you. You draw a small arc, then you draw another arc, and the point of intersection, you join them to the endpoints, and that's the triangle. Okay, that was the first case where I gave you the 3 sides. Now, what if I gave you 2 sides and 1 angle? Now, no need for the compass. You only use the compass if you are going to draw a triangle with 3 given sides. Now, 2 sides and 1 angle, you only use a ruler and a protractor. And the steps are very easy. You draw one of the sides. You put the protractor on the end point. You draw, for example, 40 degrees, 30 degrees, and then you measure this line as much as I gave you, and then let us watch this video together also about the steps of constructing. So pay attention. Okay. So first draw the first line, 7.5, using a ruler, okay? So we need to use a protractor, of course. and passes through the point, but I need it to be 6 centimeters. Okay, don't forget it's 6 centimeters. You should make it, okay? So this is 6 centimeters, and now you remove the ruler and join the third line. This is 40 degrees. The third line. Okay, so it's very easy. You draw the first line, you draw the angle, you draw the measure of the second line, and then you join the third line. That's it. Okay, guys? And this is the triangle. Great. Now that's it. Now let us go for the third case, which is one side and two angles. And this is very easy. It's very easy because you draw the line, you draw here the angle using a protractor, and the another angle using the protractor, and the point of intersection, you just join them, and they are the vertex. And let us also watch this video. It's very easy. This is 6.5. And now we don't need the ruler. We just use the protractor. Till 30. Okay, so we remove now the protractor. To join the line with the point, the end points. This is step 2. You can extend the line as much as you want. You already know this. Now we are going to use the protractor draw the 50 degrees. Also using a protractor, mark an angle of 50. Also using the ruler, you join them. You join the endpoint, another endpoint with the marked 50 degrees. You join them. And now, as you can see, we have two intersecting lines. And where did they met? It's the third vertex. Okay, you can erase the extended part, which is we don't need it actually. I just need to stop on this intersecting point. And this is the triangle. Okay, so I think it's very easy. So when you want to construct a triangle, you have three cases. Either I give you three sides, or two sides, one angle, or two angles, one side. Okay. So for three sides, you use the compass, a ruler and a compass. Two sides, one angle, and two angles, one side. You need a ruler and a protractor only. Okay. So now let us go for the third objective, or the fourth objective, and the last one for this video is when we need to calculate the missing angle in a triangle. But before we start, we need to know that the sum of angles in a triangle is 180. So in a triangle BEC, okay, we are given that the angle BEC is 40 and the angle BCE is 80, and we need now to calculate the third angle, which is EBC. First of all, you have to write BEC plus BCE plus EBC equals 180, because we already learned that the sum of angles in a triangle is 180. So the first step, pay attention to the writing. You have to write in this way, okay? So the first step is something I know. What I know is that the three angles, their sum is 180. The second step is what's given. It's given that angle BEC is 40 and angle BCE is 80, but I still need to find EBC. In the third step, I add 40 and 80, we get 120. So 120 plus EBC equals 180. What's EBC? What's the measure that we added to 120 to get 180? It's 60. So we calculated the missing angle. So guys, please pay attention to the steps. We have three main steps. The first step is something I know, which is the sum of angles is equal to 180. The second step is we put the given. And the third step, we calculate. Okay, let us make more examples. If you look at this figure, we have a triangle ABC. It's right at B. Okay, so ABC is a right triangle at B. And AC is the hypotenuse. Okay, this is a revision for the particular triangles. Anyway, you should know that ABC plus BAC plus ACB equals 180. How did I know? Because the sum of angles in a triangle is 180. Now I put the given. I have the angle ABC 90 and the angle BAC 52. I still need to find ACB. In the third step, we do a calculation. 90 plus 52 is 142. And now I ask myself, what's the number I added to 142 to get 180? We subtract. 180 minus 142 is 38. So angle ACB is 38. Another example, look at this figure. We have a triangle EFG and it's an equilateral triangle. How did we know? Because it's coded that the three sides are equal. So angle EFG, EGF, GEF are all 180 because the sum of angles in a triangle is 180. Every time you need to write this statement, okay? Now, I don't have any one of them given, right? But we know that all of them are equal because it's an equilateral triangle. So what I'm going to do is to divide the 180 among 3, so it's 60. So every angle is 60 degrees. And now the last example we have an isosceles triangle ABC of main vertex A. How did we know that of main vertex A? Because AB equals AC. And now ABC equals ACB also, because it's an isosceles triangle. Let us start step by step. So we are going to say that ABC plus BAC plus ACB equals to 180, because the sum of angles in a triangle is 180. Now let us put the given. The only given that we have is that the angle BAC is 30. So what I know that ABC and ACB, both of them together, they are 150. How did I know? Because the A already took 30. So the remaining angles, which is 150, is for both of them. But we know that ABC equals ACB. How did we know? Because it's an isosceles triangle. So we divide the 150 among 2 because they are equal. So we get 75 degrees. You have to practice them alone. Watch the video one more time. The main important things are to construct a triangle and to find the missing angle in the triangle. Please watch the video several times. Hide the answers and try to do them by your own, especially those ones that are how to find the missing angle in a triangle. And after watching it at least 2 times, you have to solve the worksheet, which is direct to the lecture. Okay? Good luck. Hello, grade 6. In this lecture, we are going to continue explaining chapter 3, which is triangles. In the previous lecture, we explained how do we construct a triangle and how do we find a missing angle in a triangle. But in this video, we are going to construct special lines in a triangle, and specifically we are going to talk about heights, medians, bisectors, and perpendicular bisectors. All these terms are familiar to you. We used to find some of them for segments, but now we are going to explain how do I find them inside a triangle. The first thing I'm going to explain about is the height, or the perpendicular, or the altitude of a triangle. And the height is as a segment drawn from the vertex perpendicularly to the opposite side of this vertex. And to draw a height, we usually use a set square. And in a triangle, there are 3 heights, and those 3 heights are concurrent, or they meet at the same point, and this point inside inside the triangle, we call it the orthocenter. Let us watch or let us see the steps together. So first of all, we need to remember, what does right mean? A right angle actually is an angle that measures 60 degrees, and some of the angles are bigger than a right angle, and some of them are smaller than a right angle. So the bigger we call it obtuse angle, the smaller we call it acute angle, and the angle that makes 90 degrees, we call it a right angle. We see like a box in the corner, it indicates that it's a right angle. Let us draw a perpendicular line from a point to a line xy. So suppose we have this point A, and we need to find the perpendicular from A to xy. So of course we are going to use a set square. Of course you have to think very well, what do we do? Because it's something we already learned before. Yes, so I need to use the set square, and I put the set square like this. So I put the set square like this? Of course, no. The sides of the set square, one of them should be on xy and the other should pass through A. So I need to rotate the set square like this. So one of the sides, it should be on xy, and the second, it should pass through A. And now we draw this line, and this line is the line perpendicular from A to xy. And don't forget to put this box that indicates that you draw a right angle. Now suppose we have this triangle ABC, and we need to draw a perpendicular line segment from A to BC. So the first height is going to be from A to BC. Of course, I'm going to use the same steps that we did before. So we are going to use the set square. I'm going to put the set square on BC, and it should pass through A. So you should put the set square on BC, and it should pass through the point A like this. And we draw the height. Okay, so we draw a segment joining A with BC as you see. Okay, so this is the height. This is our first height, AH. Okay, so the same steps should be done for the others, because you know we can draw three heights, one from A, one from B, and one from C. So what's the height? It's the distance from the vertex to the opposite side of this vertex, which is BC, right? So the height is the segment drawn from the vertex to the opposite side, which is BC. Okay, so as you can see, this is the height. This is the definition, is the perpendicular line drawn from the vertex to its opposite side. Okay, how many heights can we draw in a triangle? We already said that we can draw three heights. A height from A to BC, a height from B to AC, like this. This is the second height from B to the opposite side, which is AC. And the third height is from C to AB, also using a set square like this. And this is the third height. Okay, so this is the first height, AH, from A to BC, from B to AC, and from C to AB. Now, if you can see, we say that three heights are concurrent, okay? They are concurrent. So those three heights, they are concurrent at a point, and this point we call it orthocenter. So the intersection of three heights is called the orthocenter. Okay? So we are done from the first objective, which is constructing the heights in a triangle, and we learned that the point of intersection is called the orthocenter. Let us now continue. Now, the second thing we are going to talk about is the medians, and it's very easy. From the word median, you can see that it's related to the midpoint. So the median is a segment drawn from the vertex to the midpoint of the opposite side. So it's not perpendicular, it's to the midpoint of the opposite side. And to draw the medians, it's enough to use a long ruler. So the first thing we have to do is to find the midpoints, then join them with the vertex. Also, the three medians are concurrent and they meet at a point, we call it the centroid. Okay, let us see together the steps. So suppose here we have suppose here we have this video. So those are the steps. Let us see them together. So suppose we have the triangle. Okay, this is 6 centimeters, and this is 3, and this is the third side. Okay, so the first step, as we said, we need to find the midpoint of each side. So the midpoint of 6 is 3, the midpoint of 3 is 1.5, and this is the midpoint of the third line. And now we join the line, which is from the segment to the midpoint of the opposite side. This is the second median, and this is the third median. And as you can see, and as I told you, the three medians, they meet at a point. We call this point the centroid of the triangle, or the center of gravity of a triangle. Okay? Now the third special line, which is the bisector of a triangle. The bisector, it's actually a line that divides an angle into two equal angles. And in order to draw the bisector, we need to use a protractor. And the three bisectors also are concurrent, and they meet at a point we call it the incenter. And now before we start, okay, so first of all, we are going to talk about the bisector, or the angle bisector. First of all, let us remember, how do we find the bisector of an angle? So suppose we have this angle ABC. We say that BD is a bisector of angle ABC because it cuts the angle into two equal angles. And how do we do this? It's very easy. We just use a protractor. Okay, so this is ABC. In a triangle ABC, we have three angles. So I need to find the three bisectors of the three angles. So first of all, we draw AD, which is the bisector of BAC, that cuts the angle into two equal angles. Now BE, it's the bisector of ABC. It also divides the angle into two equal angles. And now CF, it also divides the angle ACB into two equal angles. And as you can see, the three bisectors, they meet at a point. This point, we call it the incenter. Okay, so we call it the incenter of the triangle. Okay. This is the incenter of the triangle. Actually, incenter is the center of the circle inscribed or inside the triangle. So if you draw a circle inside the triangle, this incenter is the center of this triangle. So I want you just to see it. Of course, I'm not going to ask you to do the circle, but it's good to see the circle that we are going to create inside this triangle. This is the circle, see? So this is the center, and this is the circle, which is included inside the triangle. So when we say the incenter, which is the center of the circle inscribed, I mean the circle that it's included inside the triangle. Okay? Now the last special line, so till now we learned the median, the height, the bisector, and now the perpendicular bisector. So the perpendicular bisector is a line which is perpendicular to a side, not any side at its midpoint, not anywhere, it's specifically on the midpoint. So in order to draw the perpendicular bisector, I need a long ruler and a set square. And the three perpendicular bisectors are also concurrent. And this point, we call it the circumcenter, or in another word, it's the center of the circle circumscribed or around the triangle and not inside the triangle. Let us see also the steps. So first, I'm going to draw a segment AB, and the perpendicular bisector, we find the midpoint of the segment AB, and after finding the midpoint, with the help of a set square, we draw a perpendicular line on this midpoint, and this is the perpendicular bisector. What we know about the perpendicular bisector is, other than it passes through the midpoint and it's perpendicular, is that any point on the perpendicular bisector is equidistant from the extremities, or it cuts the segment into two equal parts. and any point is equidistant from the extremities. And now let us try to draw the perpendicular bisectors of the three sides in a triangle. So first of all, we have a triangle PQR. I'm going first to find the perpendicular bisector of each one of them. Those are the bisectors. Okay, so don't yeah, the bisector is something and the perpendicular bisector is something else. Okay, so the perpendicular bisector, as you can see, this is the perpendicular bisector of the first line PQ, so it passes through the midpoint and it's perpendicular. And now the perpendicular bisector of the second segment, which is QR. The perpendicular bisector is not necessarily passing through the vertex. Okay, so keep this in your mind. The bisector, it's drawn from the vertex. The median, it's drawn from the vertex. And also the height is drawn from the vertex. But the perpendicular bisector is not necessarily drawn from the vertex, okay? Also, as you can see, the three perpendicular bisectors, they met at a point. And this point, we call it the circumcenter, because it's the point where I can draw a circle that passes around the triangle. Okay, so we call it circumcenter. Okay, I wish that it's clear. That was everything in our lesson. It's very easy, but I want you to go back to the lecture before. How do I find the missing angle in a triangle? How do I construct a triangle? Because, for example, in this worksheet, when I ask you first, I'm going to ask you to construct a triangle. After constructing the triangle, I'm going to tell you, for example, to draw a height, or to draw a median, or to draw a bisector. So how to construct a triangle, you should remember it before. How do I find missing angles in a triangle? This is also very important. Anytime I would ask you about any a missing angle inside a triangle. For example, if you have a triangle and I ask you to draw a height, you know that here I have 90 and I gave you this angle, I would ask you to find the angle above. So all these objectives are related, okay? So I advise you to watch the lecture before, which is lecture 4, and then watch this lecture and join them together in order to finish this lesson. Actually, it's the last lesson in our semester. We are done from everything. And this one is very important and it's very easy. So it's very easy. You just need to draw a height, a median, a bisector, and a perpendicular bisector. That's it. Okay?